Yeah. Introduction, and then I'll hand over to Nick. My name is Balaji. I lead the engineering teams in AstraZeneca, and we have Prabhu, who's also a software engineer in our team. We're very happy to partner with HashiCorp. This is a mix of Chennai DevOps Meetup as well as the Chennai HashiCorp user group. The first time we're partnering with HashiCorp, we're going to do every quarter. That's the plan. And today we have Nick from the UK. Thanks very much, Nick, for your time today. He's going to talk about Nomad, how you can use Nomad to your applications very high. I'll hand over you to Nick.
Awesome.
Right. Yeah.
How's everybody doing?
Doing good.
Like that? It's not like, hey, awesome. How's everybody doing? Tough crowd.
Very good.
All right.
I think they're probably tired. It's a long, tiring week.
Oh, I bet you. So what we're gonna have a look at today, I'm gonna run through some of the sort of the features and capabilities of Nomad, which is the scheduler by HashiCorp, and I'll show you how it's really simple to configure, how it integrates really well with console, and how you can sort of perform features like health checking and service discovery, load balancing, and some awesome things like that. And we'll also go into a little bit of theory, because I think it's quite interesting personally on the kind of the process behind how scheduling works. And this is kind of not exactly specific to Nomad, but there's a sort of a process around it, so we can have a look at that too. Right, so let me see if I can share my screen with you all. Which button is it? There we go. And of course, you get the crazy tunnel of doom whilst I flip to my slides. Awesome. Can everybody see that okay?
Yes.
Fantastic. So I'm a developer advocate at HashiCorp, and I've been with the company for almost a year now. My background is all things software engineering. So I'm not a DevOps guy. I'm a software engineer and a software architect by trade, and I wrote a book on microservices, specifically concentrating on Go, because that's sort of the primary language of choice for me at the moment. And HashiCorp have got a suite of tools. So we kind of launched everything maybe like 4 years ago, a little bit more, with Vagrant. And Vagrant is a tool for kind of provisioning and creating sort of dev environments and all sorts of things like that using VMs. And that was a Ruby-based tool. And then we kind of started to sort of level these things up. We looked at the ecosystem around DevOps, and we were like, you know, there's some tooling that's needed. We need a better way of managing infrastructure. So we introduced things like Terraform, and we introduced Packer and Console. And the concept around those three tools was, you know, you should be working immutably. You shouldn't be kind of following this practice of applying incremental updates onto your software infrastructure. Yeah, so your infrastructure. You should be doing it immutably, because if you do things immutably, you've always got a known state that you can get back to. So the concept around Terraform was obviously that you have infrastructure as code. So you have this very declarative way of describing the state of your infrastructure. And Packer was all about building those AMIs. So it was about shifting from provisioning infrastructure and then provisioning applications on top of it, but to kind of create these application images and then use those to be sort of deployed. Because again, it's all about getting to a known state. I should be able to take my Terraform configuration, run it, and I should be able to get an exact duplicate of what existed before, or maybe what already exists, so I can create my staging environments and things like that. And that's awesome. And then but then the world starts dealing with this like whole microservice pattern. I mean, we kind of figured that service-oriented architecture was good, and it was a step in the right direction, but there was still problems around the management of these large applications. I mean, these kind of large monolithic applications are difficult from a cognitive perspective for a software engineer, but also they can be really difficult to scale. There's kind of like only so far you can scale a monolithic application. You can kind of increase the size of the box that it's running on, but then you end up with bottlenecks further downstream, such as in your data layer. So you scale your data layer, and then all of a sudden you realize, well, I can't scale my data layer anymore. So I need a new pattern. So we kind of thought, well, hang on, let's just decompose these monoliths, make them smaller, and then we can have multiple databases and multiple front ends. And it allows us to kind of increase both our availability and go for this sort of highly available patterns, but also it allows us to scale better. And the thing that we've noticed in a trend over the last few years, and I don't think I need to explain this to anybody, but the internet is everything. So this was like a really big thing. We start decomposing these things. Then we have another problem. How do we know where all of these services are? Like SOA gave us these fixed locations. We could rely on an IP address or a sort of a domain name or something. But when you start getting into microservices, and these services become transient because we're scaling them up and down, we're maybe suffering failures at a sort of a VM level, and all of this is happening transparently, we need a way to kind of manage that sort of knowledge, manage the kind of knowledge of what are the components which are healthy and where are they, and how do we configure them as well. We need distributed configuration, and Consul fits in to that part of the picture. The next sort of two steps in the evolution was that at the time, like, it was probably Marathon and Mesos that was the sort of the primary scheduler that people were using when we started getting into the sort of microservice workloads. And I'm not specifically talking Docker, I mean just kind of microservice workloads. But Marathon and Mesos is a bit of a beast. And at HashiCorp, we're like, I think we can do better. We think we can come up with a scheduler that's easier to use, that's very easy to configure, it's operationally simple. We want to remove the cognitive load on the developers and the operators of the system so that they can get on and create great features. And this is Nomad. And of course, security, super important when you're dealing with any form of system these days. There's been a lot of problems recently, and there will be a hell of a lot more problems. So Vault is kind of trying to tie everything together from a security perspective. So Nomad. So let's have a look at some of the sort of the features and the capabilities of Nomad. And before we kind of dive into it, let's look at the architectural overview. So how would you set up a Nomad cluster? Well, the key thing is that I'm going to sort of talk about an application cluster which is using both Nomad and Consul, because these two work incredibly well together. So what we do when we're generally setting up a sort of a Nomad cluster is that we have a cluster of Nomad servers, which generally sitting in an autoscale group. And I apologize, I'm going to use sort of AWS concepts, but this is totally transferable to scale sets if you're using Azure or autoscaling groups in GCP. But you have a cluster of these Nomad servers, and we don't need a huge number of Nomad servers. They're kind of responsible for dealing with things like allocations and stuff like that we'll get onto in a bit. But you need a quorum. So if you want high availability, you need 3 or 5 or 7. Generally, you don't need to go beyond that. And Console as well. So you want a kind of a cluster of console servers. Now, both console and Nomad are exceptionally lightweight binaries. So if you're kind of just spinning up your first cluster, there's no reason at all that you can't run a Nomad server and a console server on the same VM. So you can start sort of very, very simple. As your load and your scale and things like that grows, then you maybe want to kind of split the clusters out so that you've got a Nomad cluster on its own autoscale group and a console cluster in its own autoscale group. But perfectly fine in the beginning to run both of those on the same VMs. Then what you have is this concept of this agent. So the Nomad agent is the thing that's doing all the work. It's the thing that's running all of your jobs, and it's making sure that the applications are up. So you put those in a separate autoscale group, and you're going to run many, many, many more of these than you are just that sort of simple quorum of servers. Some of our clients who are running Nomad, I think Citadel are running like 20,000 agents. So that's 20,000 nodes in a Nomad cluster. Barclays in the UK are currently going through deploying their Nomad cluster, and that's going to be a huge cluster as well. So from those 7 servers, you can manage an incredible number of agents. Now, when it comes to console, again, the same sort of rules apply. You can have a huge, huge number of console agents which are running off the same console server. And there's a very well-known electronics manufacturer whose name I can't mention, but they're running 250,000 agents connected to 7 console servers. Incredibly scalable. So we're going to start with console, because one of the beauties of Nomad is that Nomad can auto cluster. And this is a big thing when it comes to operational simplicity. It's a big thing when you start running your clusters in autoscale groups. You don't want to have to keep rejoining clusters. You don't want complicated bash scripts or any other sort of startup exec scripts when a new node comes online. And the way that console can do that is because of the way that it's built around the surf protocol. So you have these servers, and the servers are responsible for storing your state. They're responsible for doing things like leadership election and the various other sort of server functions, and they all sort of sit in that layer and talk together. Now your Nomad client, which again is a single binary, and this is next to your application. So you may have one on every Nomad node, or you potentially could put it in every Docker container. But the agent is kind of like a thin client. It's like a proxy. So when you want to make a request of console, such as where is this particular service, then you talk to your local client, and the local client talks to the servers. And the reason that you do that is because the client is using the gossip protocol. So the client is listening to messages from the server. The client knows the locations of all the servers. It knows which ones are healthy. And it's a much better place to manage that logic. The other benefit to sort of running these clients is when it comes to service discovery and health checking. And we'll get onto that in just a second. So the console agent, it's a long-running process on every node. It runs in either a client or a server mode. It's accessible with an HTTP API. And one of the other key features, which I think is really nice, is that it's got built-in DNS server for service catalogs. So if you're not at a state where you want to be kind of using sort of full service discovery capabilities, you can actually use DNS SRV records to be able to query the console service catalog. And Seth wrote a great blog post, which you can check out on our website, where he talks a little bit about this and how the capabilities such as this can be integrated into Nginx for an HA proxy for load balancing. Okay, so let's look at the interaction. So your console agent is actually the thing that does the health checks on your services. So it's not the server that does the health checks, it's the local agent. And this gives you the capability of distributing the load. It allows the server to be incredibly sort of robust, because these local console agents are kind of got a much shorter path to the services that they're health checking. So in this sort of typical setup, you have a load balancer, and the load balancer obviously needs to know how to contact service A and B. So what it will do is it can talk to console. Console will then report back the healthy services, and the load balancer can then route the calls on for you. So the gossip protocol, this is the thing that's used for the communication between the server nodes and for the client nodes. It uses our surf, and surf is built into the backbone of console, Vault, and Nomad. And it's a swim-based protocol. So from a sort of a health checking perspective, it uses this kind of round robin sort of approach. It has capability built in for robustness, such as that it isn't just going to sort of mark a service as unhealthy because one agent says it's unhealthy, because what if the agent itself is under load? So it's a very robust protocol, and we use this very, very effectively for health checking, membership information. And again, just recapping, that distributed failure detection, sharing the work by your cluster. So how do you create a console cluster? Well, it's actually really easy. You basically throw a bunch of nodes into an autoscale group, and you tell console to use autojoin. And what autojoin does is autojoin will use the cloud's metadata to be able to discover the other nodes and to be able to form a cluster. And this is supported by AWS, Azure, GCP, IBM, Alibaba Cloud, and a whole bunch more. And the way that it works is that when console starts, it uses your configuration, and it will read the AWS metadata. It'll then talk to AWS, and it'll say, hey, give me a list of all instances that are configured with these tags. And that gives it back its IP address. And it can then use that to be able to join other servers. So configuration-wise, actually really easy. So this is an example configuration file from your console server. And to be able to get console to auto cluster using the auto join capability, you add this one line. So this is the one in bold, retry join. I tell it I want to use AWS. I tell it the key that it needs to be looking for, and then I tell it the value that it's expecting in that key. And if you sort of look at some of the tags, it's literally just using plain AWS tags. From a client perspective, so this is the thing you're running on every single one of your worker nodes. Exactly the same thing. I mean, very simple configuration, very straightforward. And again, we're using that same retry join capability. So the clients don't even need to know where the servers are. They can discover this in the initial set through the metadata. Then, because they're hooked into the gossip protocol, they're going to get all of the updates. So Nomad. I've talked about console for a very specific reason, because it's relevant to Nomad. So Nomad has exactly the same sort of principle. You have a bunch of servers. The servers will always have one single leader, and we'll discuss why when we look at the planning and allocation. And then we'll have multiple clients. So the servers are used for accepting jobs. So if you want to schedule a job, you talk to a server. They're responsible for managing clients, so they'll they'll be checking to make sure which nodes are healthy. And they work out what the best way is to actually place your jobs, to be able to distribute them well across each of the nodes. The clients, well, they sit there and they sort of talk to the Nomad server and they'll say, hey, you got any work for me? And they also control the task lifecycle. So they'll make sure that your Docker containers are running or that your applications are running. Now, the way that Nomad auto join works is that when you start a Nomad server or a Nomad agent, Nomad talks to your local console agent. And because console already has discovered its console cluster, when Nomad starts, Nomad registers itself with console. So when the second Nomad server or agent starts, it queries console and it says, hey, give me the list of all of my peers. And once it's got that, it can get the private IP addresses, and then it can join. So it'll again auto join the cluster. Super, super simple. Configuration-wise, very similar to what we had with console. Like, there's not a lot of elements in there. We're specifying here a region and a data center and a few of the advertised properties. So what IP addresses do we want to be advertising for our HTTP API and the RPC for gossip and surf and things. And we're saying we want to enable the server. Now, Bootstrap expect is probably the most interesting line in this, because what this means is that the Nomad server, when you're auto joining it, it will not start accepting jobs until 3 servers have joined that cluster. And you can set this to sort of whatever you want. You can set it to 1 if you want, but we recommend always setting that to a number of the quorum. Now, once things are up and running, that doesn't mean that if there are only 2 Nomad servers, the cluster will not work. It's literally just for that startup Bootstrap. For our Nomad client configuration, again, very, very similar. There's no real difference. If you have a look, the only thing is that we've got a server block instead of a client block, and that's it. Like, really, really easy to reuse. Very, very, very sort of basics. If you don't want to use console, and why wouldn't you want to use console? Console's awesome. But let's just say you don't. Well, you can actually cluster your Nomad without having to use console. So you switch auto join off and you specify a list of servers. And this can just be a list of domain names or IP addresses or whatever you sort of want to use in there. So in our config, I mentioned regions and data centers. And this is a kind of an interesting concept of the way that Nomad allows you to build up these clusters of clusters. Yeah, anyway, but you have the concept of a region. So a region is an independent cluster. So for example, I could have region A, and this is Europe. And I have region B, and region B is the US. Now, if I federate these 2 clusters together, if I join them, the 2 regions together, then I can talk to a single Nomad endpoint and I can schedule jobs to either one of these regions. It just kind of makes things a little bit more simple rather than having to sort of maintain a number of different endpoints that I've got to interact with. The other benefit of this is some of the things which we're going to see in the next 12 months, such as the capability to do regional failover. So you could have all of your jobs in Europe, and if a European region goes out, you lose all of AWS or whatever in Europe. All of those jobs can automatically federate over to the US, so you have 0 downtime. Or it could be region A could be AWS, region B could be GCP. So there's a lot of great things coming with Nomad. So a data center, well, this is kind of like, Europe West 1 or something like that. So you might have, say, Ireland and London. It's kind of that concept. If you're dealing with AWS, you've got data centers which are made up of availability zones. So I kind of want to spread things around to be able to get my highest fault tolerance. AWS usually say that you potentially are going to lose maybe 1 maximum of 2 availability zones in the DC, but you should never lose everything. So if you kind of distribute your servers across those principles, then what you get is a capability for incredibly highly available clustering system where you can lose an entire data center in AWS without losing your entire cluster. So just to recap on that. So the servers in a cluster only look after one region. So if I've got 2 regions, Europe and America, my European servers are only calculating the scheduling and placement of jobs in Europe. They will not have any impact on America. All they're doing is forwarding the requests. And data, again, at the present is not replicated between the regions. If you lose a region, you've lost a region. But there are ways to deal with that until we bring those features in line. So scheduling of jobs in Nomad. So these are your core principles. You've got evaluations, allocations, you've got nodes, and you've got jobs. So the jobs are the things that you submit. They represent the desired state. They represent the applications that you want to run in the system. And a job is, if you're familiar with Terraform and the HCL syntax, we use exactly the same concepts for Nomad. It's trying to be really declarative about what you want to do. What are these tasks? And the tasks themselves, so these are your applications you want to run. You can bind these to constraints because, hey, maybe I need this task to run on Windows. Maybe I need to run it on ARM. Maybe I need to run it on a GPU instance or a particular sort of scale of instance which has more networking bandwidth than usual. You can kind of control this on a very granular level. And the way that the tasks get mapped to the client nodes, well, this is your allocation. So the server determines, when you run a job, what the allocation plan should be, which tasks are going to run on which client. And the whole process looks like this. So we're going to step through this a little bit more in detail. But you can see that you have your server nodes, you have your schedulers, and you have some of the internal concepts such as an evaluation broker and a plan queue. So when is an evaluation created? So an evaluation is, I have the desire to make a change to the running instances on this server. When does that change? So this will run when your external state changes. So, this could be a node change. It could be that your desired state changes, such as you sort of manually invoke the update through a job, or things like emergent states or node failure or sort of larger sort of system failure. All of these will cause a reevaluation. So again, registering a job, updating, or node failure. So we have these different concepts of these schedulers. So a scheduler in terms of Nomad, you have a service, a system, and you have the batch scheduler. So a service scheduler, these are kind of your traditional microservices. So these are your application runs that you want to sort of place in the cluster. A system scheduler is something that you want on every single node. So this could be console. It could be things like statsd. You might be choosing to run something like HAProxy or Nginx as a reverse kind of proxy or a load balancer. And batch schedulers are for like fast, batch jobs. So you can kind of create a job in Nomad, which might be encode a video. And you can run this job, but it'll only actually execute when you trigger the batch. So it's a kind of a nice way for running those ad hoc jobs. The other thing you can do is you can actually run periodic jobs. So if you don't want something running all of the time, maybe you just want like a cron type job, then you can sort of schedule that with Nomad as well. So there's a flow. So this is the flow. This is how Nomad determines where a job will be placed, on which node. So the first step is that the scheduler, which is on the server node, and you're going to run a scheduler per call on each of your servers. So it runs an evaluation plan. And an evaluation plan is, this is what I would like to happen. So it kind of works out roughly where best to kind of place these nodes. And it works out what it needs to do. Do I need to remove some applications? Do I need to add them? And all of these sort of these simple steps. It then goes into a sort of a feasibility step. So what it does in a feasibility step is it looks at all of the nodes in the cluster, and it works out which ones are actually available to place these tasks. So these are things like which ones have capacity, which haven't got their reserved CPU or memory, which ones satisfy any constraints, such as I specifically want to be running on a Windows node or a Linux node or a particular flavor of Linux. And then it goes into a ranking step. So the ranking step takes all of these feasible nodes, and then it tries to place the tasks in the best way that's going to optimize the usage of your cluster. So kind of like stacking things in a cupboard. It goes through a bin packing step to work out the best way to ensure that your cluster is most utilized. Once this plan has kind of been created, the scheduler then submits it to the leader. And the reason that it's submitted to the leader is because you've got to think that if you've got 12 schedulers running concurrently, they're all trying to plan and place these tasks on their current knowledge of the system, which means that they're optimistically concurrent. So what happens is the leader acts as that broker. So the leader, when it receives a plan, it adds it to a plan queue, and it runs through the plan queue sequentially. And it does this to make sure that it's not oversubscribing any of the resources, it's not overplacing anything. If the plan is okay, so if the leader agrees with the allocation, if the leader agrees with what the scheduler has kind of recommended, then it'll go ahead and it'll create an allocation. If there's a problem with this, it's going to present some feedback to the scheduler. It's going to say, hey, I can't present this task to this particular node because it's busy. And the reason it's busy is because somebody in the plan queue is probably, taking your resources. So the scheduler can then go back and do a reevaluation. When it's okay, it goes ahead and it creates the allocation. So this is the locked down map of where all of these tasks are going to be placed on these nodes. And it creates the allocation plan. It'll acknowledge with the scheduler that everything is okay. And the nodes, when they're regularly sort of polling the server, looking for jobs, they're going to pick up these pieces of allocation, and they're going to go ahead and they're going to start running those tasks. So how do the tasks work? Well, what we do is we define things in this HCL using a job file. So this is about as simple as it can get. This is a job which is titled Redis. I'm declaring that I want to only allow this to be deployed to US East 1, which is the name of my data center. This is just a list, so I can give this multiple options in here. And a job contains a single task. Now, a job can contain multiple tasks, but in this instance, it's just a single one. So we give the scheduler a hint. We say, hey, we want to use the Docker driver. Now, in terms of drivers, there's a number of different capabilities. You don't have to just use Docker. You can use single binaries, so you can proc exec things. You can use Java, so for fat binaries. You can use QEMU, LXC, Rocket. There's a whole sort of bunch of capabilities, and each of the drivers has its own specific configuration stanza. So in this instance, for Docker, I'm using, again, the absolute bare minimum, which is telling it which image to use. So I want the official Redis, and I want you to use the tag of v13. What I also have to do, though, is I have to give it resources. And I have to allocate these resources because this is how the sort of the allocation and the planning is working. It's how the bin packing working. And this is the same on just about all of the schedulers out there. So you say this particular task can use a maximum of 500 megahertz of CPU and a maximum of 256 megabytes of RAM. And I'm also setting up some network where I can do things like configuring the ports, which are going to be available to for configuring in Docker. But a job doesn't have to just create contain a single task. I can use a group stanza if I want, or I can just define individual tasks. When I use a group stanza, what I'm actually telling the scheduler is that you need to place all of the tasks in this group on the same node. So I'm telling it that I want my Redis task and my application task to be placed on the same node. So this is incredibly useful. You might be wanting to keep your applications, your application databases or something like that as close together because you want to sort of get the best performance out of them. So constraints. Constraints are really, really useful. And when you're operating a large cluster, sometimes you might need to be able to have to set a constraint to be able to say, hey, I need this application to be running on a particular kernel version, because it might not be a Docker application, right? It might just be a standard binary. Or I could say, you know, this application is very, very, very CPU intensive. I want it to be running on a particular node type. So I'm gonna tell it I want it to run on a 16x large machine. This, of course, could be a GPU instance. It's incredibly configurable. And some more examples. I mean, I can determine the CPU architecture, so whether it's 386, AMD, ARM, the number of cores that the node has available, whether I want Linux or Darwin. Because, of course, Windows, you know, you don't have to just be running a single cluster. I can have a cluster which is built up of Raspberry Pis, which is built up of Windows nodes, Linux nodes. Hey, if you want to, I can even run some stuff on a Mac. Nomad is incredibly flexible on where it will run. And of course, if I want to use some AWS metadata or something like that, then actually I've got the capability to do that as well. And in the docs there at Nomad Project Docs Runtime Interpolation, you can find all of the examples of the constraints. It's incredibly comprehensive. But we talked at length about console. And the reason was why we did that, because service discovery. Now, service discovery is incredibly, incredibly important when you're building microservice systems. It can also be a bit of a pain in the backside to set up. But when you're using Nomad and you've got Nomad paired to console, actually Nomad does a lot of the heavy lifting for you. So again, in my task stanza, what I can do is I can specify this service stanza block. And this is going to mean that when Nomad starts an application, it's going to register the application with console. It's not only going to register it in terms of the service catalog in console, but it's going to set up health checks in console. So here I'm saying very basic declaration. I want you to register the port Redis. And I'll look at some more formal configuration in a second. And I want to register a check. Now, I want this to be a TCP-based check because I'm just using Redis, and it'll use the port that's defined, and the interval is every 10 seconds. Any of the capabilities that you've got in console in terms of the way that you can register your health checks, you can use TCP HTTP, or if you want to use script, this is all there in configuration in the stanza block. Artifacts are super, super useful. Because, again, what if we're not running a Docker container? What if we've got a fat jar that we want to execute? Well, you don't have to run any complicated installation scripts. What you can do is you can use the artifact block in Nomad. So you can use an artifact block. You can pass it to a source, give it the destination directory, and this is local to the allocation. Set up things like checksums, and it gives you that capability that you can, when you start a job, Nomad can download the artifacts before it executes them, giving you that like super, super simple workflow. In addition to using artifacts for your application binaries, you can actually use your artifacts for things like templating. So we've seen GitHub as an example, seen basic HTTP. If you store your stuff in S3, then actually you can use an artifact as well to retrieve something from an S3 bucket. So you configure things like your access key and your secrets and your token. And again, Nomad can go away and can pull those resources. Now, templates, configuration templates. So even if you're using like Docker, quite often you need to provide some form of custom configuration to your application. And when you combine sort of Nomad artifacts and Nomad templates, then it gives you this really, really rich way of building up that configuration. So I can download my template artifact, and then I can use Nomad to process that. So Nomad's got all of the capabilities that console template has, because actually console template is built into Nomad. So you can do things like using simple environment variables, and here I'm referencing the IP address of my health port, and I'm specifying the port. But I can also do things like I can use the various different templating features that are built into console templates, so I can query my service catalog. And of course, like console template, when any of those things change, I can get Nomad to send a notification to my application. So I could sig hub it, or I could sig term it, or however you want to do that, it's all incredibly configurable. We'll have a look at the way that Vault integrates in a little while, but this templating is extensible beyond just basic configuration. You can use it to configure your secrets, and you can use it to configure things like TLS. So blue, green, and canary updates. This is kind of like basic stuff that should be the core of any scheduler. We need to be able to update our applications, and we need to be able to do it in a way that's non-disruptive. If I deploy an update to my application, I should have no downtime while the new version is coming up and the old one is being torn down. And Nomad gives me the capability to use these update blocks, so I can configure all of this. So in this instance, I'm saying whenever I update a job, it'll do 3 application updates at any one time. It's going to rely on console's health checks to determine that things are up and healthy before it starts tearing down the old ones. And we've got some sort of deadlines in there. Auto revert. This is a really useful block, because if you, for example, make a mistake, you try to run a job and you're updating a Docker image, and the Docker image has got a misplaced tag or something like that. You don't want Nomad to try and schedule that with a misplaced tag and leave your application in a broken state. What would actually happen is Nomad would fail the job, and it will create a new job which is based on the previous. So you've got that fail-safe way of ensuring that if you make a mistake in your job file, you're not going to end up with a broken state on your application or your scheduler. And you can do canary updates as well. And what a canary update will do is a canary update will bring new containers, if we were using Docker, and it will schedule those. So if I started off with 3 and I specify a canary of 3, then I'll end up with 6 containers, and they'll run side by side. Now, with a canary, I have to manually intervene in the process. So I have to either manually tell Nomad using the CLI to promote that canary to production, then it will tear down the old version, or I could do something from my CI flow, or I could maybe use some of my monitoring hooks and using the API, because everything in Nomad has a full API backed with all of the features that you see in the CLI and stuff like that. Of course, it makes it really easy for us to integrate things like Vault and Console into Nomad, because they're all our products. So they can have that linked roadmap. And while they work incredibly well independently, and you can use Vault with Kubernetes, and you can use Nomad and Console, or you could use Console and Mesos, they do work incredibly well together. And what I can do is I can use Vault blocks inside of my tasks. And what Vault's going to do is Vault's going to obtain a token for me. So if I have a Vault token, which is relating to my CDN or my front end policy, Nomad can do that, can manage that communication with Vault, and it will update that token and make it available to my application by setting it inside an environment variable. And of course, whenever that token changes because the TTL is about to expire, again, Nomad will manage the process of updating my application with that updated token. And because of that, we can do some really cool stuff. So we can actually tell Vault to create us SSL certificates. So we can set up, again, our policies in Vault. We can set up our keys and our certificates using the PKI endpoints. And when a Nomad job starts, we can use this console template block, and we can tell we can ask Nomad to make a request to Vault to generate us a certificate that we can use for SSL, TLS term, and we can also get the private key and the certificate chain. So it just makes things really, really easy to kind of manage that microservice infrastructure. We've got the capability of service discovery. We're looking after our secrets because we're using Vault and we're injecting our secrets via Vault into our applications through Nomad. We're generating our TLS certificates. We don't need to worry about the complexities of managing internal TLS between all of our microservices because Nomad can kind of handle that broker for us. Some of the features that you're going to see next year is actually this is going to make it even easier. And what we're going to be able to do is bring some capabilities where Nomad will assign those SSL certificates automatically for you. So it'll be almost again back on that zero configuration. I probably talked way too long. So let's have a look at a quick demo. What I have is that screen big enough for everybody there?
Maybe zoom in a little more, please. Right.
How's that? So I've got a Nomad cluster running. And let's just take a look at one of these jobs. So let's have a look at Fabio. So I'm just using the command line here. And if I do Nomad status autocomplete, which makes things really nice, Fabio. It's telling me here the ID, it's telling me when the job was started, the type. So in this instance, it's a system job. If you remember, that means that it's going to run on every single node in a cluster. Now, one of the things I didn't mention about system jobs, if you add a new node to the cluster, Nomad will automatically make sure that those system jobs get added into it. It's running in the data centers DC1. It's not a periodic job and it's not a parameterized job. It's just a plain old job. And you can see that we have 3 instances running there. The allocations, these are the allocations, so the placements of each of those. And I can look at those a little bit more detail. I can say Nomad alloc status 9C8, whoops, 9C8. I can autocomplete that. This is just going to take a second while it's talking my remote cluster in AWS. It's getting all of that allocation information for me. And when it comes back, come on. Come on. It will come back, I promise you. Oh, and there we go. I was just about to tell you a joke. So we can see that this particular allocation, so this is 3 instances, this is just one specific instance. I can tell that I've allocated 500 megahertz of CPU, I've allocated 256 meg of RAM. It's got 300 meg of disk available to it. These are the ports. So I've got my admin port, my HTTP port, and then I've got some log information such as the task was received by the client at 22 minutes past 12. It built the task directory. So it created the local volumes, downloaded the image from Docker Hub and started in 2 seconds. So it was fairly quick. What other stuff can I do? Oh, yeah. So I can see things like this. So I can see that I have the number of nodes which are attached to this. And let me see if I can get this to this is my local Nomad cluster that I've got not running on my MacBook. I'm actually running my my Nomad server, my local dev server, on a Raspberry Pi, which I've got stuck under my computer. So this is a Raspberry Pi 3. It's running Nomad on it, and I've got a Nomad agent running on my MacBook Pro, which is actually really, really useful because it means that that thing never needs to be switched off. But it just shows you the flexibility. Literally anything you can compile Go for, you can run as a Nomad node. Now, some of the things that we've introduced recently is the UI, and the UI is something which is going to become more and more feature rich as we sort of roll things forward. If I just look at that Fabio job that I was running previously, I can see all sorts of things, such as the job definition that I submitted. So I can sort of look through this and I can see the name of it, Fabio, single instance, and the various sort of task settings. So the configuration around my Docker, some environment variables that I'm setting up, load balancing. It's just a really easy way to get some information about the running state. It's read-only, and that's never going to change. You're never going to be able to interact with your Nomad cluster through the UI because, again, you should be applying concepts of infrastructure as code and having that scriptable workflow that always enables you to get back to the known state. But for just finding out basic information, checking out things like the endpoints or having a look at some of the jobs, this is all available in the UI. Some of the stuff that's going to come into this in the next release, we're going to have the logging that's available as well. So your service, if it's outputting any logs, you'll be able to easily get access to them through here as well. I can see all of the clients that are running. So in this particular cluster running here in AWS, I have 3 client nodes. So let's wait for that to refresh. So my server, I have a single node, but in my autoscale group, I've got, oh, come on, AWS, make it easy for me. Single node in my server, you can see that instance there, but my client nodes, I've got 3 nodes. And actually, while I'm here, why don't I prove to you how easy it is to update that. So I'm going to just scale that up. I'm going to have 5 of those whenever it gets around to it. Again, we can drill down. We can see the particular allocations which are on that individual node, and we can get some sort of information around the health. So it's just a way of being able to kind of drill through, and it's a very, very quick and easy, useful tool. So okay, we've got 3 nodes right now, but as soon as AWS brings those up online, we'll actually see that change. So job file. So what I'm running here, so I can show you how the updates work, is I've got a simple application, and this is just doing HTTP. It's just called HTTP echo. It's basically just going to output hello world 1. We'll go through some of the configuration aspects. I'm telling it my console address. I'm giving it some arguments to start, the image that it's going to use. I'm specifying the port map. So I'm telling Docker that this application uses port 8083. Now in my resources, this is where I tell Docker to expose port 8083 to the client node. Now, in this instance, I'm not specifying anything, which means I want dynamic port allocation. However, I could just by simply putting in this configuration here, I could specifically tell Docker that I want port 8083 on the client node to be mapped to 8083 into the container. Service discovery settings, I want it to use the HTTP port. I'm just giving a name, and then I'm specifying some tags for console, which actually Fabio is using. And then I set up my health log. So to run that, oh, actually, let's update it. So let's update that to V3 will do. Whoops. Okay. If I quickly just fill that, you can see that's coming back as hello world 1. And if I run it, you'll see that that has changed there. So again, what we've got is that rolling deploy, and that happened a little bit too quick. So we'll kind of go back and just do that again. Oops. Sorry, I'm struggling with my keyboard trying to talk and think at the same time. So we got 3. Let's change that back to 1. So we've got status there. Run that. Still running V3. You can see that the allocations are going through. Starting to get V1s coming through now. So you can see that you've got a mixture of 1s and 3s as it's slowly rolling things in. And we've got 2 placements out of 3 currently running. If you look at the left-hand side, that's going to change in just a moment. I think it's doing like 1 every sort of 10 seconds or so. And that looks like, there we go. Everything is now switched over to the old version. So, super, super, super easy. I'm trying to think what else I can show you, but that's pretty much everything. We got, oh, it's brought those new instances. There you go. I created that auto scale group. I increased the number from 3 to 5. You can see there that we've now got 5 nodes in our cluster. I didn't really have to do anything there to configure that. If I have a look at that same thing in my Nomad window, we've got that here. Now, what you can also see, if you have a look at this, is that each of these nodes already has some allocations on it. Now, if you remember what I was saying about system jobs, where a system job will run on every node. So as I've auto-scaled my Nomad cluster, because I had a system job which was configured and running already on there, as soon as those nodes come online and contact the server, Nomad is telling them that they need to be running these system jobs. So it's automatically placed those. I haven't had to do a single thing. And again, everything works exactly the same in reverse. let's just turn that back down 3. I can run that, and then as soon as AWS has made the modifications to that group, you're going to start seeing all of these changing, and everything will replace itself, because Nomad will determine that nodes have disappeared and it needs to reallocate. And if I can work out which button it is, no, I don't want to hide the participants, to disable the screen sharing. Okay, that's it, gone. That's it. How easy. I hope you're all converts. I hope you're all going to run away and download Nomad, because it's free, open source, and fantastic. And does anybody have any questions?
Yeah. Would Nomad handle stateful applications? Like, would it be able to deploy stateful applications?
So, yeah, you can. I mean, there's a concept of an ephemeral disk, where you can actually create a volume and you can make it sticky, so that if an application gets replaced into a different location, then the disk will move with it. But I'll be brutally honest with you, for scheduling stateful applications, I'm still feeling kind of old school on that, and that I do quite like sort of using a managed cloud service. So just from the pure simplicity, if I need a MySQL, I'll generally use an RDS instance, or I'll use a managed instance. But you do have the capability there, yes. You can use ephemeral disks.
Another question, like even Mesos uses a gossip protocol, right? How is Consul this Nomad different from Mesos?
Well, I mean, so I used to run a Mesos. Well, I didn't used to run. I used to interact with a Mesos cluster, and one of the things that I had was the operational complexity around that. So you needed Zookeeper, you needed the Zookeeper cluster, you needed the Mesos, so you needed your Mesos master and your Mesos agents. You needed to run potentially Kronos on top of that as a service. You needed to run Marathon. There was a kind of a lot of stuff to actually sort of load up on top of there. Now, when it came to doing service discovery, what we actually used to do was we ran a console cluster for our configuration management and also our service discovery. We didn't use the Zookeeper cluster. Zookeeper was purely and simply only for Mesos' state. So you can actually run a hell of a lot less in terms of application instances by sort of running a Nomad console cluster.
Thanks.
Any more questions?
Just look back. Another question, you talked about monitoring hooks, right? About when we update application, the blueprint deployment. A short brief on that monitoring hooks and what are those?
Yeah, so the monitoring using sort of for the Canary deployments, I think that was probably the bit, or was it the health checking and monitoring through console?
With reference to Canary, and that also arises like if we need to monitor services and things like that. So which kind of tool can be used for monitoring?
So you can use, let me quickly just share my screen again. So you can use anything really, because what you want to do is you want to interact with the the console, sorry, with the Nomad API to let it know that a particular job has is good. So I'm a big fan of Datadog. I used Datadog in my previous company when we used to run the system, and it got us through a number of sticky instances. So, for example, you're using Datadog, or maybe you're using Prometheus and Grafana or something. It doesn't necessarily matter. But in all of these systems, what you can do is you can do things like configure monitors. So I could have a monitor here. What have I got? Let's create a new one. So I'm just going to do a basic metric monitor, and maybe I want to say, let's say when the deploy count from my particular group, when it's above, I don't know, 0.2. These are just numbers. So what I can do is I can actually monitor a particular service. So this could be my, let's say this is errors. So my error threshold. So if I do a canary deploy and I deploy a new bunch of services into my production environment, I could have a job which says, if the error level does not escalate, and maybe some other factors, then I can assume that that new canary is healthy. And what I can do, if that sort of satisfies, is I can set up a trigger. And again, just using something in Datadog. Datadog has a whole bunch of integrations. It actually has a Nomad integration, which I've not actually played with. I only found out this existed. Okay, so this can allow you to get metrics on cluster health and availability. Or maybe I just want to do something simple like, where's a webhook? I'm sure I can do webhooks in here. There we go. So based on that monitor that's going to be sitting, watching my Nomad cluster, if everything's all and well, then I can trigger a webhook. And basically the webhook is just a call to my Nomad API endpoint, which is going to promote that canary into production. So you've got a number of ways to do it. You can do it automatically through your sort of monitoring stack. You could do it manually. Maybe you've got it through a sort of a QA flow or a Jenkins job that the QA would manually sort of trigger. But there's a number of different ways to do it. It's very much on your organization, where you are in terms of your maturity around sort of working with canaries, and also your appetite for risk. So there's no real one solution for everybody, but it allows you to build and craft a solution which will work really well for you, I think.
Thank you.
How many of you there have used Nomad before? No one?
I installed it, but I installed it. I couldn't get time to use it.
You may.
Nick, I have one related to networking. Do we have for Nomad or custom networking drivers? How's that?
Oh, sorry, that didn't really pick up very well. Could you?
I was asking about custom networking drivers.
Yeah.
Do we have a custom networking driver to create custom networks for application-specific networking? How is that?
So Nomad doesn't support that directly yet. So we're looking at implementing the CNI interface over the next sort of couple of quarters. If you're using Docker, however, you can actually configure your Docker server to use. You can configure Docker with your network driver, because Nomad is independent of Docker itself. It only talks to Docker via the API. So if you want to run something like Weave or Calico or something like that, you can configure that on the box with Docker, and then you can just show your containers. But Nomad doesn't yet have specific implementations around the CNI interface.
That means if we have used for a particular application port on same host?
So ports themselves are, you can either dynamically or statically allocate them. So if you're sort of dynamically allocating a port, then Nomad is just going to choose one at random, well, not random, randomish, for you. So you're never going to end up with a port clash when you're using sort of dynamic ports. With things like dynamic ports, when you're using console, you don't need sort of static ports, because actually you can use either service discovery for your end applications, which need to discover the IP and the port, and they can do that either through DNS SRV records or making a direct IP call to console. Or if it's for things like just web services, then one of the common patterns is to use a reverse proxy, such as Nginx or Fabio or HA proxy, something like that. And you set that as a service level running on a known port, and then you can just have Nomad configure the various different routes and proxy those through to the dynamic ports. Is anybody going to make me happy at the weekend and say they're going to go and have a play with Nomad?
Yeah, sure.
Yeah. Nick, do we have the images locally, like instead of going to the Docker Hub feature with the Nomad?
Yeah.
Yes.
So what you can do is you can run your own private registry, and that's generally the best way to do it. So you can actually run a Docker registry as a Docker container. So rather than running the Docker images from like the individual node, and which can cause a problem that if nodes are constantly transitioning. If you run a Docker registry, then you point all of your application jobs to the local registry, and then that's basically your proxy. So you can either use that as a gateway out to Docker Hub if you want to be able to do that, or you can literally just store local images in that known location. And that's the best way to do it, rather than having to try and provision an image on each application node. And seriously, running Docker registry is super easy these days. You can literally just run it as a container.
Right.
So you.
Okay.
Any more questions? We close here now. Great. Thanks very much, Nick. Thanks for your time in the presentation. Personally, I've not used any of the HashiCorp tools, including Nomad, but my platform team, sorry about that, but I'll give you the good news as well. That my platform So my platform team, I will have a play with Vagrant at least. But my platform team produce most of the HashiCorp tools, including Nomad, Vagrant, Console, and Terraform as well. So right now they're working on the new version of a platform, so that's why they haven't been able to keep it today. but they will be talking about success stories probably in the next meetup, probably in February or March. We'd like to hear more from the community, how we're using HashiCorp tools and finding success, and even challenges as well, and get to hear from the experts like them.
I'm genuinely not saying this because I work for HashiCorp, because I'll be brutally honest with you, there's only one reason why I work for HashiCorp, and that is because I use the tools when I was building the systems, and because of my experiences with working at not on the high street and getting through 2 Black Fridays, and my old colleagues have just got through a 3rd without a single incident, because we built everything around Nomad and Console and Terraform. It just kind of highlighted to me that there was a so much nicer way of doing things, that this stuff just works, and it makes my life easy, and I sleep well, and those things are a big bonus to me. So yeah, don't seriously, don't take my word for it. Everything is free to try. Everything's open source. Just give it a go. And you know what? If something sucks, let me know, because I genuinely would love to hear about it so that I can feed things back and make things better, because we don't want to create sucky products. We want to create amazing stuff that people love and is easy to use and allows them to get lots of sleep and not have to spend time typing at 4 o'clock in the morning.
Yeah, fantastic to hear that. I know a couple of my friends are in another company. They're true HashiCorp fans. They know HashiCorp really well. What are the things, but it really, really well. I keep saying that, so I do echo that.
So here's an early release piece of information for you. Nobody in the world knows this yet, okay, literally, and nobody will know about this until January. But we're going to be doing a mini conference.
1 second. This is on a live stream, and people will be watching this video maybe even later. Do you want to say this?
Well, I can't tell you. Well, I can maybe make a maybe sometime next year in Amsterdam, there's going to be a mini HashiCorp conference, and it may be a couple of days, and it may be full of loads of great information, and it's going to be superb fun, and you can hear from the best people in the industry about services and systems, operations and DevOps. And maybe you should all just get yourself a ticket, come over and hang with us and have a great time. And if you're not convinced by the time you get there, you will be by the time you leave. And I know it's hard. It's a hard ask to ask people to spend 2 days having fun listening to some great tech conference in Europe in the summer. But you know, if you work on it, you can do that.
My boss, he goes to pretty much every HashiCorp. He's based in the UK, so he goes.
It's yeah, it's going to be fun this year, and of course we're going to be doing all of the videos for HashiConf last year are online now, so they're on our YouTube channel. There's some really great stuff. It's not just people talking about theory. It's industry practitioners who are using the tooling to solve real world problems and explaining how they did it. So there's a lot of good technical info and technical tips on those talks that they're not just kind of marketing spiel. We don't do that at our conferences.
Yeah. Thanks very much, and thanks for your time. Have a
pleasure.
Good weekend.
You too.
Yep.
Enjoy your all weekend. Bye.
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 Stop the broadcast now.